In this question, we are dealing with averages. And when dealing with averages, our preferences are either, first, to focus on the total sum of the items averaged, and second, to focus on the fact that the differences of all the elements from the average must sum to zero or balance out. Let's move to the data statements separately first. Statement 1 gives us a pretty healthy chunk of information. We can compare sums of these elements. If the average of the 7 highest scores is 95, then those 7 scores sum to 7 times 95, or 665. We desire to know whether the sum with the lower 3 is greater than 10 times 90, or 900. The question, therefore, is whether the remaining 3 make up the difference, and the difference is 235. Since the minimum score is 80, the bottom 3 must sum to at least 240, which is greater than 235. Therefore, the sum of all 10 must be greater than 900, meaning the average of all 10 must be greater than 90. We are able to answer the question definitively, so statement 1 is sufficient. Statement 2 gives us less information because we know nothing about the top range of these numbers. The average of the lower 4 numbers is 85. In one possible case, the upper 6 could average to 86, and in that case the answer to the question is no. The averages of all the tests is lower than 90. In another possibility, the average of the upper 6 is 200, and the answer to the question given to us is yes. Since we can obtain, in valid cases, opposite responses to the question, we have insufficient information to answer the question definitively. Therefore, statement 2 is insufficient. The correct answer is A.